So in the last video, we were talking about the dilutions and I stopped. So this, oh, what's going on? This is the concentration of potassium hydroxide in A. And here we have the concentration of potassium hydroxide in B. And we add it up and find the total. The total is equal to 0.21 molar. So we note, remember significant figures. Right, okay. So in this one, what we're going to do is, again, we're going to do a dilution. And we have 1 drop of 0.20 molar sodium bromide, and we're adding it to 100 milliliters of water. So if we do my old volume and new, we have the sodium bromide concentration is equal to 0.050 milliliters divided by 100.050 milliliters. Remember, we've got the added 2 times 0.20 molar. And it's equal to 0.00010 molar, or 1.0 times 10 to the minus 4 molar. So once again, we have 2 significant figures. All right? Okay. In this one, we have, we have 5.0 milliliters of 3.5 molar nitric acid and 9.95 milliliters of 0.2. So we're going to have to do the A and the B again. So let's call this A, just because it's first, and this one B. The concentration of nitric acid A is equal to 5 milliliters over our total, which is 100 milliliters, times 3.5 molar, which equals, now I'm going a bit carried away with the significant figures in here, 0.175 molar. In B, the nitric acid concentration is 95 milliliters over 100 milliliters times 0.20 molar, which equals 0.190 molar. We add it up and we get our grand total is equal to 0.365 molar. But once again, we have to write it in the right number. Significant figures, 0.37 molar. And I forgot to do that important thing of going back through and canceling out units. Let me check to see if we did this. Okay. Good. So with this one, we're taking a stock sample of nitric acid, which happens to be as strong as it can get, 15.4 molar, and we want to dilute it. So I think we should do the M1V1. M1, M2. This of means it's linked, so it's V2. M1V1 equals M2V2. So 15.4 molar times X equals 0.375 molar times 2.50 liters. We're going to isolate the X, and we get X equals 0.375 molar times 2.50 liters divided by 15.4 molar. Once again, we are going to cancel out these units. We're left with liters, and we're going to have an answer in 3 significant figures. Yeah.
Hi Liz, how you doing? How'd you meet you?
That's Mr. Kozak making comments. So, what we could write down if we were going to write an answer for this, we could write this. In order to prepare the solution, we are going to measure out 60.9 milliliters of concentrated nitric acid and add it to enough water to make 2.50 liters of solution. Now, quite frankly, I hardly ever do that. I usually just stop with the 0.0609 liters. Okay, so let's look at the next one. M1, V2, M2. The of means they have the same numbers. So X times 14.6 molar equals 45.0 liters times 0.060 molar. We're going to isolate the X, and X is equal to 45.0 liters times 0.0600 molar divided by 14.6 molar. Cancel out those repetitive units, and we get 0.185 molar. Final answer. So, let's see. Okay, in this one, we've got 2 solutions. We've got solution A and we've got solution B. So we're going to work them out, add them together. So the concentration of KCl in solution A is equal to, oops. Okay, we're going to do this a couple of different ways. It's equal to 0.335 moles divided by the total volume, 300 and 250, 550.0 milliliters equals, continue on, and KClB is equal to 0.804 moles divided by 550.0 milliliters equals, and then we're going to find the total. Okay, the reason I stopped is because I have to get out a calculator. Okay, 0.335 divided by 0.5500 equals 0.609 molar. Please note that even though I didn't write it down, I changed that to liters. And the point 0.804 divided by 0.5500 equals 1.46 molar. Add them up. 0.09 equals 2.07 molar. Okay, what I was going to show you was the other way of doing this. And I hate to do this, but we're going to have to slide down the page where we can see. We're going to put total moles over total liters equals 0.335 plus 0.804 moles over 550 milliliters, 0.5500 liters, which equals 2.07 molar. Okay, just another way of doing it, probably more straightforward. So going back, with this one, we have a volume and a new volume. So the easiest way to do this, I would think, is to do NaCl concentration new is equal to 500.0 milliliters over 300 milliliters times 0.750 molar. Milliliters cancel out, and we get 1.25 molar. So just before I turn this thing off, I just want you to remember that there are 3, 4, 5 different ways of doing the questions, and as long as you show me your work and you cancel your units, it's a-okay. All right. Done.